One of the next techniques we talk about is integration by parts twice. When you perform integration by parts, remember you get uv minus integral v du, and that second integral needs to be evaluated. And what occasionally occurs is the integral v du is an integral that itself requires integration by parts. This is an example of using parts twice. And so the first thing I want to do is recall from our basic algebra. This is way back in basic algebra. If I have a is equal to some expression b plus c minus a, you want to solve for a, you can subtract the a off to the other side. And then don't think of it as divide, think of it as multiply both sides by 1/2, and you generate a is equal to 1/2 times the expression. So if I have a on both sides, this is going to come into play here in just a little bit. So I want to just sort of brush up, get some of the cobwebs out of our memory here a little bit. It's going to come into play here in just a little bit. So I want to do integration by parts, and so this is the product of transcendental function and an algebraic function. So we're going to do parts, and what do we have here? Parts. So we have u and du, we have dv and v. dv is the most complicated portion whose antiderivative we know. U is everything else. The derivative of u is 2x dx. The antiderivative of cosine, that's the whole point. The antiderivative of cosine is sine. All right. And just to be sure, we can check the derivative of sine is cosine, so we know we're correct. And so this is, what I'm going to do here is what I have not been doing before here is I'm going to write this left-hand side, the original expression first, and say, what is this equal to? So this is the original problem, the original integral we're asked to compute. And I'm going to throw in here uv v du. uv, so that's to multiply these two, uv, minus the integral of v du. This constant multiplier 2, I'm going to throw out in front of the integral. And then that's 2, v du, so that's x sine x dx. So that's uv minus integral v du. There's v, there's sine of x, and du is 2x dx. So we have all the players on the right spot on the stage. But now we have to evaluate this integral. That integral also requires integration by parts because it is the product of two functions, at least one of which is a transcendental function. So we're going to do parts again. I'm going to do parts just on this portion. And I'm going to go ahead and bring this along. So this is minus 2 times. Now everything in this bracket is going to be the expression I'm going to compute here, right? And I need uv, I'm going to put it over here to the side, u, du, dv, and v. Same song, second stanza. So I want the most okay, you got that. The most complicated portion whose antiderivative we know. U is everything else. The derivative of x is the derivative of u is the derivative of x. And what's the antiderivative of sine? Yeah, the antiderivative of sine is cosine. No. What's the antiderivative of sine? Which is it positive or negative? Well, one of two ways. Either you know it, the integral of sine is negative cosine. If you did this, if you wrote cosine of x, you should check, is the derivative of cosine sine? No, it is not. So you drop the negative sign. The antiderivative of sine is negative cosine. I need to put my negative there. And now reconstruct uv v du a second time inside these brackets. So everything here is inside these brackets. This is uv, so let's just be very careful with our negative signs. uv, negative x cosine x, minus, because of integration by parts, the integral of v du, that's another negative sign, So everything in here is this integral with the 2 multiplier. No, we got negative signs galore here. So this is, these are going to cancel. These are going to cancel, but this one remains. And so I think if we can put this all together, this becomes, distribute this -2. This becomes plus 2x cosine of x. This becomes minus, right? Negative, negative, negative is still negative. Now, what's the taking care of all the negative signs, what's the antiderivative of cosine? Yes, the integral of cosine is sine. And we've distributed the 2. I better be careful here. I got to distribute the negative, but also the 2. And we're lumping all the constants together in the constant of integration. But here's the issue. This was the original expression to start off with. So we had to do parts twice and be very careful with all these negative signs. So there are times when you have to do integration by parts more than once, parts twice, and it falls out. It's probably not too hard to see if this were, notice what happened here. We started with x to the second, and when we went through parts the first time, we created x to the first. And then we did parts the second time and got the result. It's not too hard to see that if this had been x to the third, we go through parts the first time, you would generate x to the second, and then you go through parts again, generate x to the first, and then go through parts again and be finished. So this procedure can repeat itself in principle. And there are sort of memory devices you can get to work your way through that. But in principle, the idea is sometimes you do parts and sometimes you need to do parts again to see what's going to happen. Now, the next example, that's where this is going to come into play. I kind of showed this to you a little bit early, but that's going to come, we'll show where that's going to come into play to be able to see what happens if you do parts twice and you start chasing your tail. So that's going to be the next example we'll work on.